In this video, we are gonna prove another supporting theorem, namely this one. We are gonna use it to transform our representation of Fourier series, algebraically transform it to a more convenient form. Now, this is a simple trigonometric identity. There will be no analysis, so we're just gonna get straight into it. I'm gonna use a graphing calculator to verify that I haven't made any mistakes while I algebraically manipulate this expression. So I'm gonna algebraically transform it and verify that I haven't made any mistake by looking at the graph. The graph doesn't have to change. So I'm gonna multiply and divide this expression by 2 sine of 1/2 x and also divide. Correct? Now, here we have a product of a cosine. Let's just move this multiplier over here. Here we have a product of cosine of alpha and sine of beta. We can transform this product using a simple trigonometric identity. I won't prove it, but it's very simple to prove. You can do it by yourself. Here we have sinus alpha times cosine beta. That's exactly what we have here. Now, on the right hand of equal sign, we have sine of alpha plus beta. Let's substitute alpha plus beta. So sine alpha plus beta plus sine alpha minus beta. Divided by 2. You see, expression hasn't changed. So I'm gonna work with this expression from now on. Let's cancel out the 2's. Alright. Now let me just change the order of terms in here. I want to move the minus sign out of this sine function. Since sine function is uneven, I can just move this minus sign over here. So change the position of terms, carry out the minus sign. Yep, still the same graph. Alright, now let's take this sum and expand it term by term. Let's write out the terms of the sum explicitly. Sine of 1/2 x. Let's just change the order here also for conveniency. Sine of 1, this is the first term, x, plus minus sine of 1 x minus 1/2 x. This is the first term. The second term, we just substitute a 2 for an I because we sum over I. And let's write out the last two terms. We sum from 1 to n, so the term next before next to last term will be n minus 1. And here let's substitute the last term n. Now let's simplify the sums, the terms that are in the arguments of sine functions. The terms in the arguments of sine functions. 1 plus a half is 3 halves. 1 minus a half is a half. 2 plus a half is 5 halves. 2 minus a half is 3 halves. N minus 1 plus a half is n minus a half. N minus 1 minus a half is n minus 3 halves. N plus a half remains n plus a half. And n minus a half. Now what you can see, there are terms that cancel out. The first term cancels out with the fourth term. The second term doesn't have anything to cancel out with. And if you were to write this out further, it would be very messy, but you would also recognize that this term has a term to cancel out with. And I'm just gonna go out on a limb here and say that the only two terms that remain after we cancel out, after everything cancels out, are gonna be this one and the second one. Now let's check if the graphs of the two expressions coincide. Yeah, this is exactly the same function. This is not a proof, but this is. Alright. Now, and we also had to remember that we had to divide by 2 sinus 1/2 of x. Alright, so let's replace this expression with the summed up part, the summed up representation. Yep. So as you can see, we got the same graph as when we were just writing out sum over I from 1 to n of cosine ix, right? So no mistakes here. And now let's just distribute this multiplier to sine of 1/2 x minus a half. Here, this is what we were going to prove right here. Sine n plus a half x over 2 sine 1/2 x minus a half.